Hey everyone, glad to have you here assisting another event under the initiative GDG Tech Sessions. Here, Carlos Abreu from GDG Madeira introducing this session for you. With these sessions, we intend to keep sharing knowledge about diverse tech topics from speakers around the world and make it available independently of where you are. So feel free to replay and share the previous tech sessions at our YouTube channel. And of course, we hope that you enjoy a lot what we've prepared for you. Before starting the session, don't forget that if your community wants also to propose a tech session, just fill this form and we will contact you to further details. The speaker can be from your community or a friend of yours with contents and skill to share. Keep in mind that you can always propose an event, even if you don't belong to a GDG chapter. These tech sessions can also be proposed for any GDG, Women Tech Makers, or Developer Students Club that have some content to share to the community. And today, Rustam, a Google developer expert for cloud and a passionate computer scientist, will present to us how to build data pipelines using Java and Apache Beam. But also, there is an opportunity that we have to know a little bit more about GDG Cloud Oslo and their community. We will use the Slido platform in order to facilitate your communication with the speaker. Just post your questions and Rustam will reply it at the end of the talk. Like before, the link is in the description of this video. So, without taking much more time and before starting the Apache Beam tech session with you, Rustam Mehmandarov from GDG Cloud Oslo.
All right, thank you very much. First of all, I would like to say thank you for having me. This is really great to be here. And you also asked me to say a few words about our GDG chapter, and I would like to say a few words about that. So we have quite a few GDG chapters here in Norway, but so the one I am representing at right now is the GDG Cloud Oslo. We have been around for quite some time, for quite a few years now. Normally we would run meetups almost more or less every month. Now, after the kind of lockdowns and the virus and global pandemics and all those kind of things, we moved all our meetups to online platform. So the plan is the same. We're kind of trying to do it as often as we can. Before summer we had something almost every week, every second week we had online events. We are about to kind of get started after for the fall half of this year. We'll about to start with new meetups, and since we're doing it online, it's a great opportunity for everyone, any of you who are watching, to join us. So I posted the links in the presentation there. So we are both on Twitter and on Meetup. And also, if you have any talks that you want to present or even co-present, if you want to do a talk for instance, for our chapter and also GDG Tech Sessions, that would be amazing. Then we'll be happy to host you all as well. I guess before going over to the topic, I can also mention that we're also working on a dev fest that will be on 14th and 15th of October with all the other GDGs from Norway. So they're pretty much all around the country. There is a GDG Oslo, GDG Cloud Oslo. There is Bergen, Trondheim, down at the southern part of Oslo, of Norway. There are a few there as well. So we are quite a few chapters that are working together to putting together an online edition of a DevFest as well. So it's going to be fun. And it's a different times, but we're trying to make the best out of it with the online events and stuff like that. I guess I'll jump over to this to today's topic now, and today I would like to talk to you about this thing that I've been playing around with. So I am for me, I have I would like to share my experience and also give you an introduction into this thing of data pipelines. And I probably have to say that I'm not a extreme expert on Apache Beam that I'll be talking about, but I'll be talking about my experiences and things that I had to go through, and kind of solving a fun problem, or solving a problem in a fun way. But we'll get back to that. So until then, you can just kind of sit and wait in excitement to hear what kind of problem I was actually about. I was talking about, and I will be solving in this talk. Before we get started, I usually think it's a kind of fun way to get started is to show you the vision, or the other end of the project, kind of more closer to the finalization of the project. So I would like to start with this, and so I'll have to disconnect my headphones for a second so you can actually hear what's happening, but I'll be back in a second. Um, so hey Google, what's the bike availability at the stop next to my house?
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
All right, interesting. So this is kind of the thing that we want to get to, and we want to produce at the end, right? So, but let's start now, kind of rewind back and start from the beginning. So what was actually the problem, and what I was trying to solve with this data pipelines, and at the same time, what kind of useful things that I can bring out of this experience, so you can maybe try have a look at that and have a go at that product as well. So the thing I'm talking about, and the bikes I was talking about, are those. So you probably have those wherever you are right now, or wherever you're watching this video from. They are pretty much everywhere, all around the globe. So you have the ones you see on the right there, the blue ones are from Oslo. So that's where I live, here in Oslo, Norway. And the other ones are the red ones on the left. They are from I think it was Belgium that this picture is from. So it's pretty much the same kind of bikes. I mean, I've seen the same ones in, I don't know, Madrid, San Francisco, anywhere really. This is the bikes that I'm talking about, and the concept there is basically you buy a kind of membership, and then you have some kind of way of opening, like a card or a mobile phone app or whatever, so you can actually just unlock unlock that bicycle and bike it wherever you want, and park it at the next kind of lock like this, and well, that's it, right? So you just pay kind of yearly whatever fee, or monthly fee, or whatever that is in your case, and then you can use it as much as you want. And that sounds really, really cool and nice, right? And this, I asked the company that is doing this in Oslo, and I was like, hey, can you give me some really cool promotion pictures and everything you can use in presentation? So they did, and they kind of, so I got pictures like this. This is really nice. I mean, it's summer, it's warm, it's green, there is a lake, you're just biking next to it. Well, things can't be better, really. This is another picture of kind of the same thing, also from Oslo, where it's pretty close to where I live right now. And same idea. It's like warm, it's summer, and it's nice and everything. And well, this is how it is. Summers in Oslo, they are quite often like that. But the problem is that, like, a few months later, or well, quite a few months later, after this kind of weather, you might experience something like that, and then it gets a bit more kind of well, less nice. This is obviously not the promotion pictures that I got from them. This is another picture. So it might get a bit cold and snowy and everything. But, well, let's talk about the nice weather and all this kind of the warm and beautiful part of the year. Well, don't get me wrong, winter is really nice as well. Probably not for biking, though. But anyway, so this is how the pictures that are kind of the marketing department sells you, right? There's a lot of bicycles available. You can just pick one, go anywhere you want, and it's like really, really nice. The problem starts when you actually need your bike, because what would usually happen, or what quite often happens, is that whenever you need a bike, probably a lot of other people need a bike as well. So, for example, you want to go to work, or you want to go to university, or I don't know, to meet friends in the evening, or whatever that might be. But then there will be more people in the same time and the same kind of and going in the same direction in the same time period, right? And that's a bit of a problem, because what you usually would experience, instead of those really nice pictures like that, and instead of like pictures of full racks of bikes just like lining up one after each other and like pick one whichever you want, you might experience something a bit more like this. So this is a picture of a stop right across the street from my office, and this is kind of the picture I took on the right, and then on the left you see what the picture actually quite often looks like. So it's the same bicycle rack, or whatever you put the bicycles in, but it's empty, like totally empty. There is not a single bike, and there's a lot of locks there. You can put a lot of bicycles in there, but all are taken. So this is usually a problem, and this is what usually happens. And this is then from the same angle, but the same thing, right? Empty racks. And this is happening quite often. And that was the problem that I was experiencing. And then what happens is that you get a bit sad, right? You're like, hey, I paid for this thing, I can't use it. And if I find a bike and I go to somewhere, I don't know, say to a lake or so, or to a place where I can swim or whatever, all the locks will be full with bicycles, so I won't be able to park mine. I'll have to go somewhere else and try to find it and everything. So you see my problem, right? So you actually have access to the bicycles, but you can't find any bicycles, or you can't find any available locks to put them in when you're done. And then what happens is that like your inner nerd in you, or in me anyway, wakes up, and you're like, hey, you know what? I know coding. I can do programming. There should be a way of solving it in one way or another, as a programmer, as a developer. And then you kind of go like, okay, what can we do about that? And then I kind of started like, thinking, going back and like, thinking about like what can I actually do about that, and hatching this kind of master plan to always have a bike available, or at least know where I can get one. And the kind of the thought process was kind of as follows, right? So you start with this thing like, well, there is no bicycles available. What do we do? Well, that's a bummer. That sucks. And where can I find one? Can I find? Do I know where I can find a bicycle available? Well, I don't really know, right? How can I do that? Well, I don't know. Can I use an app? Well, there is an app for that, and it's quite useful app, and it's really nice and everything. But it usually gives you, in most of the cases, it would give you a real-time availability right now, right here, of all the bicycles. And then say you're sitting at home on the sofa and you're planning to go somewhere, and you see that there is one bicycle available at the stop that is like 2 minutes away from your house. By the time you'll probably get to that place, to that bicycle, it will probably be taken by somebody else, because, well, 2 minutes in between just one bicycle, a lot of people living around, it will be gone. So, well, app kind of doesn't really help sometimes. So what can I do? Do we have a public API? Well, we do actually have a public API that is quite limited, but still it provides you a real-time picture, and it's really, really nice. Okay, cool. Maybe I can do something about that. But again, the public API provides me a real-time data, so I don't have any historical data, and I cannot just like knock on their doors and say, hey, you know what, I need the historical data, just because I'm gonna like understand how your bicycles are moving around and stuff like that. So you need to collect it somehow, and you need to do that yourself. And then you're like, okay, cool. How can I do that? Well, I mean, I work as a developer. I work as a consultant, and we usually work on really huge projects. And we're kind of used. I mean, you're used to working and thinking in like kind of enterprise way, and you're like, oh yeah, probably I'll put everything in a data warehouse, and then I can do like cubes and everything, and reporting, and statistics and all these other things. And well, it's my pet project. I don't want to have like a server racks at home just to know when and where I can buy it. Even though, I mean, I would probably love to have server racks at home. Probably I will be in minority loving those having at home and making all the noise and and all the other things. But it would be fun. But that's another story. Let's don't go there. So what can I do about that? Well, maybe I can write something custom. Maybe I can write like I don't know, JavaScript or Python script or whatever thing that would parse the data from the APIs and put them in the right way. Well, I can do that, but that's kind of sucks because I have to do all the kind of supporting all that thing, and that really sucks. That's not really kind of fun way of developing stuff. Yeah, I still need to maintain it and everything. So I didn't really want to do that either. So what is the next thing I could do? Well, I mean, I could do something. If I had something flexible and portable and open source and all the other things, then I can just write once and run it on all the kind of things. And then you're like, yeah, well, that would be really nice. And well, I'll actually, I'll probably profit from that. Well, I mean, profit in quotes. Obviously, I'm not going to earn any money on that. It's just like then I'll have bicycles available. That would be really nice. So that was the problem, and that was kind of the way of thinking. And now I'll want you to introduce you to the concepts of Apache Beam and to explain how things works and how I use Apache Beam to solve this problem. Before I do that, I'll probably say a few words about myself. So my name is Rustam. I talked about quite a bit about this community that I'm a part of, one of the communities I'm part of here in Oslo. But also I work for a consultancy company here in Oslo, where I work a lot with architecture, Java, cloud, and things like that. In addition to that, I'm also a Google Developer Expert for cloud. So I'm a GDE for cloud, and as well as that, I'm also a Java champion as well. So I work mostly with Java and cloud, things like that. So going back to our problem. So the way I kind of tried to solve it first was to solve it with like a Raspberry Pi on my desk. And that was the kind of the first few months of the project where I was collecting data on the Raspberry Pi. And that was basically the way it would work. It was that I had a cron job that would wake up every 15 minutes. So I was doing it 4 times an hour. And then it would just like wake up and do whatever it's supposed to do, like things like collecting data, dumping it to a file, and all these kind of things. And then I would have to process it with something, batch processing with files and everything. And then I was like, probably that was the first plan, right? I would probably have to put it into something like Apache Spark or whatever to process it, put it into data warehouse and visualize it. And in case my API would use a streaming, I would do the same kind of thing, probably use something like Apache Storm or something and put it again into a data warehouse with some kind of dashboards and stuff like that. But that required quite a lot of software, the different kind of software. So Spark, Storm, all the data warehouses and all the other things that were kind of put together. And that wasn't really tempting to do it on the Raspberry Pi. So the second thought would be like, okay, can I do something that can do both? So I can do both streaming and I can do a batch processing at the same time. And then I talked to a friend of mine, a Googler, and he was like, hey, have you heard about this Beam thing? And that was quite a few years ago. And I was like, yeah, this is really cool thing that you can actually use it to. And then he started talking about that. And then I realized that I had this problem with bicycles and I was kind of trying to solve that. I was like, hey, that would be a good way of learning how Apache Beam works and at the same time can try to solve my problem. So what is Apache Beam? Well, I mean, Apache Beam has this really, really nice way of kind of run once write once and run everywhere kind of concept. So it supports batch and streaming processing. It supports also quite a few languages. So it has first it came with a Java SDK, and then the Python one appeared, and after that also Go appeared. And the cool thing about that is that they have this way of runners that you can add to the model. So you build your model, and then you can execute and run your model on different platforms. So you can do it locally on your machine with this thing that they call Direct Runner. You can do it also in the cloud. So in this case, it's a Google Cloud with Cloud Dataflow, which is a managed version of the same thing. And you have Flink, Spark, Apex, all the other runners as well, so that let you read from file systems and stuff like that, read the data from databases, wherever you want, wherever you have your data, process it in the way you want it, and put it into something, files, databases, whatever. So it's kind of cool thing, kind of cool concept. And this part of like swapping out components is also really nice, because you can just replace I don't know, a storage from S3 to Google storage, or the other way around, or read from Hadoop or whatever, and you can just like switch and mix and put things together the way you want it. And that's a really nice feature of it. So the big picture version 2.0 looked kind of immediately like this now, right? So I had a cron job now, and then I can do that dumps files to a file system, and then I can pick up those files and process it with Apache Beam. And then I could do the same thing if and when I needed the streaming thing, also with the same model, given that the data would be the same, but just with the stream. So I could actually do the same thing. And then I would put it into data warehouse and analyze it with graphs and things, and maybe even a Jupyter notebook, just to experiment with the data and see what I can get out of it. So the managed version of that, as I told you, I mean, this is just an example of on Google platform, but you can use it on these different other cloud providers as well. So it's the same thing. You have some kind of cron job, like Cloud Functions, cron jobs, or whatever, that is able to wake up every so and so many minutes and just do whatever it's supposed to do. When I was creating that, there was no cron on Cloud Functions, so I had to cheat a little bit with a little other piece, but now it works without that as well, so it's even easier. And then you can put it on the storage, store the files in the way you want, and then you actually have a managed version of that Dataflow thing that kind of wakes up and processes it and puts it in the right way. So that's the concept, right? So now I want to explain you a little bit of inner workings of Apache Beam. By the way, Apache Beam is an open source free piece of software. So it's originally started by Google, developed by Google, but then they open sourced it and gave it to Apache Foundation. So all these things are basically open source and everything, except for the things that you see on the cloud. But that's how it is, right? The managed versions and stuff that might be a bit not a part of that open source project. But the thing is that the same model runs on all of these different platforms. So it's actually kind of cool. I'll explain a bit more about that in a second. But first, what is actually a pipeline? I mean, think of a pipeline as a kind of conveyor belt where you can put together cars or put together other things, whatever it might be. You have one end where all the bits and pieces are disconnected, and there is a lot of magic happening along that line, and at the end there is a flashy new car or computer or whatever, I don't know, you're putting together on that pipeline. On the other end, that is a totally different product that ends up on like at the end there. And this is the same kind of thing with the pipeline. So the official explanation of that is it's a set of data processing elements connected in series, and the output of one element is the input of the next one. So basically, you're done with something and you put it into something else. And also the what is usually said about that, it is a directed acyclical graph. So directed, so there is a direction, you can't go back, and also there are no cycles, so you cannot actually go into a loop or something. So when you're done with your data, you're done. So then the next step comes in, and the next step comes in, and so on. So how do you do that in Beam? And that's was a bit confusing to me when I just started playing around with that. Now it's been probably a few years now since I started this project. So now I have almost probably around 2 years worth of data that I've been storing and kind of collecting about that. That's kind of fun data to play around with. So how do you write a simple pipeline? You can do it in 4 very simple steps. Before I explain you steps, I wanted to show you a little bit, to give you a little taste of data that I had to work with. So this is one of the APIs that I was working with, and that is this is the availability data for each station. So you don't know where the station is. I'll get back to that later. But for now, you just have an ID for a station, and you have a availability of bicycles and available bicycles and available locks for that station for a specific period of time. So at the bottom of this file, it would be a timestamp. So one of the elements of this JSON file would be, or structure, would be a timestamp. You can't see it because it's all the way at the bottom and it's a long file. But yeah, so a very simple kind of thing, but it's not very database friendly. You have to kind of change it a little bit to put it into a database form. So I wanted to go from this to something like this, right? So it's a bit more a tabular form where you have an ID stored where, and you have availability and locks and bicycles and all the other things. And also the most important probably thing was also adding a timestamp per each line. So kind of starting to denormalize data to make it more reporting and kind of data warehouse friendly in a way. So to go from one way to another, obviously I could have written a custom script, but I didn't want to do that. I wanted to have a model because I wanted to have it to be able to process a lot of files at the same time, which is also one of the strengths of Apache Beam as well. So the pipeline looks kind of like this. You read files, you input them, you read them, you do some things with the text lines. Then you have this part of a parallel do. I'll explain also what it is in a second. That's basically something that can be very easily parallelized, that can be run in many machines at the same time without kind of destroying the data and everything for all the other processes. And then you can store the data to whatever. So in this case, I wrote a data warehouse, but you could also do it with a file system or whatever you might want to. And then you store it, right? It might be a file, might be a database table, or whatever that works for you. First, so 4 steps, right? First step is that you define pipeline options. And by the way, the code I'm showing here is, well, as you might have guessed by the introduction and everything, it's Java. So I wrote everything, all of it in Java. And well, if you're interested, everything will be. I'll give you a link. Everything is on GitHub already. And but you can probably rewrite that into Python or Go or whatever. It's pretty much the same kind of thing. So first you define pipeline options. Before you start your pipeline, you explain where to get files, where to store them, what you want to do with them, and like how you call things, all these kind of things. And also what you can also do, you can do this at annotations where you explain what it is and give it a name to these different steps, and all these kind of things, and give default values, for example, to your variables. So for example, this one is input files. Where do I get input files? And if it's not provided from the command line, for example, I'll use the default value from default string up there and things like that. So there is more to it as well. This is just a simple example, but you line up quite a few of those options. And when you're done with that, you create a pipeline that's as easy as just this one liner where you say pipeline equals pipeline create, and then you provide the options that create it, right? So the third one is that where you actually start applying your transformations. And this transformations is this part of the pipeline where you remember you just do something about it, you output it to and then you pick it up by something else, you do something about it again, you pick it up by something else again, and this is what happens. This is the conveyor belt of this thing. And the way you do that is just by chaining those .apply methods after each other. So as you can see here, is like the first one is just the reading lines, and you can also give them names. So every transformation can have a name. So for example, my first and last one has a name, and this two in the middle don't. But so it's optional, but it's a very nice way of doing that, because then you can actually easily see what is what and where things are going and everything. Yeah, when you're done with all your transformations, so you just chain all the applies. You actually probably here I need to mention the Pardo as well. So this is also I think that we need to learn a bit more about. So Pardo is it's a short for parallel do. And it's an element of wise transformation. So in my case, that would be to kind of read all those small, tiny little files and transform them in the format I want. This can be done in parallel because there are lots of files, there are lots of objects, JSON objects, and every worker can pick up one object and do all it's supposed to do with it. And when it's done, just picks another one, another one, another one. And the framework will actually kind of try to figure out how many workers they need to process this much of data. So first it looks at the data, analyzes it, and then kind of creates the thing. So yeah, and then and then when you're done with this, you can actually I'll show you an example. So this is what I was talking about. This is the parallel do for parsing the station data. So this data that I showed you earlier, the JSON file. And the fourth step would be to run it. So now you have created your pipeline, you explain how things are, you created all your Pardos, and now you have to run it. So the way you run it, at least the Java version on my machine locally, this is what it is, right? So Maven compile, and then you provide a few options to it. So what the important thing that you probably want to mention, I want to mention here, and is that you use the direct runner. So you say pdirect runner. So because I'm running on my machine, then I specify the main class where the starting point of the program is, and then I specify some arguments, from the command line. So for example, in this case, it's input file where the files are, and it could be actually also a wildcard. So I could say data star.txt, and it will pick up all the data star files and everything. And then you define also the output folder as well. So simple, right? What if I want to run, because I was talking a lot about this. Oh, you can run this thing wherever you want, and you write the model once, and it's just magically gonna run everywhere and everything. So how does it work actually if I would have to put the same thing on the cloud? And this is in the next slide, and I will intentionally go a little bit back and forth between those two slides, just to show you the difference, so you can actually see, and it will be kind of easier for you to compare things. So I did not change anything, a single thing in my code, but then what I did change was added a few options here. So local cloud. So as you can see, the difference here is there are a few differences. So first, you do the Dataflow runner. So you actually say, now we're going to run it on Dataflow. And then you also provide some specific things for the cloud-specific things. So for instance, your files probably will be in a bucket somewhere instead of being locally on your machine, which doesn't make sense when you're using cloud. And also where the output is going to be, and all these kind of things, and also specify, for instance, a region where it's going to run. So where in the cloud we're running this thing. So I wanted to run this thing in Europe instead of running it in somewhere else. So then I had to specify that. By the way, you actually, well, at least when I was doing that, I haven't tried it running without region lately, but The reason it ended up there to begin with was that it would kind of give me a magical, really weird errors if I didn't have that. So then I had to add it. It probably is fixed by now, but I haven't tried that without really. But okay, so now I can actually, I wrote the code. I wrote my Java code is the same. I just changed a few parameters. I just press enter and it runs. And the way it looks like, so the first version of that, like reading files and putting this thing into a pipeline and like, processing and everything was just, this is how it looked in the cloud. And you can see that the pipeline is very simple. It's just one thing you put in and there is one thing coming out at the end. There is nothing magical very much. It's very, very simple, very straightforward thing. And the way it's, I think I had back then at that point, I probably had like a 3-4 months worth of data. So it wasn't much, but still, I mean, it's it's 4 files an hour. So every 15 minutes. So 4 files an hour, 24 hours a day for 4 or 5 months. So that's quite a few files, right? But then, it's still in a cloud. It processed the whole thing in 18 minutes, as you can see there in the corner. And it used a little bit more than 15 machines. So I think it was like 17 machines or something. And well, 20 minutes, that's really, really nice. If I had to use my own computer to process the same amount of files, it will probably take me much, much longer, just like running one after each other and processing these files just in file IO and all the other things. Don't forget the questions. You can still ask them in Slido. And the output would be like this, right? So I wanted to have output like this, and it worked, and it was quite good amount of data. It wasn't crazy, it wasn't big data yet, it wasn't anywhere close to big data even yet, but I mean still it was just 35 megs of data in just plain data, like the size of it. But still, I mean, it was 1.1 million rows, so it's a little bit of data to play around. It's okay to be like for 3-4 months worth of data. And then I was learning Apache Beam, so it was fun. Then I wanted to do something interesting, and this is also another cool feature of Apache Beam, is that you can actually merge 2 different pipelines into one. And basically the way you do that, you kind of have to, you can, for example, merge it on a key. So in my case, I have this file with availability on one side, the one that I showed you earlier. But then I also have a metadata about each station on the other side, where it has the same ID for the station, but it also has a description, it has the geographical coordinates of it, and all these kind of things. And now I wanted to do even to kind of denormalize the whole table even further. So for each row and each availability kind of entry into this database, I also wanted to add the information about station, just because it would be easier for me to look up and everything, and I didn't want to kind of have like foreign keys and all the other things, and just it's easier to run reporting and all these kind of data warehouse things the way you just put into one big long table thing. So the output I wanted now, like version 2.0, was like this. So now I have much more data. The tables are kind of growing in the size horizontally as well. How do you do that? Well, the other thing, it was quite a bit later in the process, and now I had quite a bit of files. Now I had 600 megs of worth of files, non-processed. I processed quite a few already, but at that point, I had 600 megs worth of text files that were not processed. So it's quite a lot of data to process. At least, like when you have small files, it takes a lot of time to open them, do something with them, and all these kind of things. So what do I do with this? Well, I run Apache Beam on the cloud. And the way I did it was to read 2 different files, to have 2 different pipelines, and then at some point merge them with a key. So in my case, that would be an ID, so the station ID. And here, that was this 600 megs of data that was running, and you could see that it was actually quite a lot of more data. So now I processed quite a few. What's that? 23 gigs. No, that's wait. I processed quite a lot more, so 600 megs of data, but now I did it faster because, well, it's a lot of time going to like starting machines and everything, but now it was just 14 minutes, so it was 4 minutes less, even though it was more files. And also I had many more workers, so that's the also reason why it went faster. So now we were doing something around, what's that, 150, around 100 and yeah, something like that, machines that were doing the same thing in parallel. And that's really, really cool. But then I ended up with, instead of 35 megs of data, now I have my table was around 1 gig. And then I had, instead of 1 million rows, I had 30 million rows. And well, I had almost 1.5 years worth of historical data that I could process, and I predict where the bicycles are going to be and everything. And all of that with very minimal changes to my pipeline. Is just like putting new files, running the job and processing it, and doing all these kind of things, which is really, really cool. But then running on the cloud, that sounds expensive, you might think. And so I thought as well, because after doing that, I didn't really think about that much. But then I got this notification because you can't see it immediately how much money you spent. But then I got like this thing that, hey, you used 900% more money or resources, or well, money than normally. And I was like, oh, this is going to be expensive. This is going to be scary. So what happened was that, well, you can, for now, you can take a guess how many euros that's under that little black box there. There is an amount of euros that I had to pay. So you can guess, you can do your guesses and like see if you can actually, if you will get any closer. So 3, 2, 1. That was the amount of money I actually spent. That was my 900% more. So 3.4 euros. That's, I don't know, a price of a coffee or two or whatever. So yeah, that was actually the whole thing. Those 160 machines running in parallel and processing it in 18 minutes. And that was just like that all I had to pay. That was really, really cool. And then you can actually see the billing also as well. It was pretty much nothing. I paid a few cents every now and then just because I stored a lot of files. But then it was like it kind of peaked at 3 point something cents, and then it kind of went down again. So, it's really, really nice. And you get a bit amazed and wow. So instead of getting like a depressed and sad puppy, you get a bit more looking, at least, well, those kind of me, getting in more into this amazed monkey kind of look, and you're like, oh wow, this is cool. So now that we talked quite a lot about the batch processing and how it was and what I did with these things, I probably am going to mention a few words about the batch process, the stream processing as well. Excuse me. Well, I'm not going to talk too much about it, but I still want to kind of explain and give you an idea of the stream and why it's so important that you can actually have the same model still. And so far we've implemented this batch processing. How do we do this going from batch, so going from processing files one by one, to this endless stream of data, endless kind of stream of fresh data coming in? And the one of the problems is that there is no end to it, right? But then the other problem is that you don't know when your data will be arriving. So you don't know when the delays are going to be. So your data for 8 o'clock in the morning can arrive at 8 o'clock in the morning. It can also arrive at again, around a bit later than 8, but 8-ish. But then it can also arrive way much later at 2:30 or something in the day on the afternoon. And that kind of sucks because now you have to do something about your data. You cannot just expect that the data will come immediately like with the batch. But the good thing is that the Apache Beam can give you a lot of help here, and it will help you with these things like the pipelines will help you with all these transformations. You can also introduce things like windowing, where you have this moving window of data and that you can look at. You can also provide things like watermarks and triggers and accumulation. So there are different ways of actually constructing your pipelines where you can do element-wise transformations, where you just convert one little piece of data into another kind of little piece of data, and that's it. Where you, for example, aggregate your data, you take two different boxes and you put them into one bucket. Or there is like a composite version of that where you kind of do all of the above and some more. So you put them, you massage them in a really advanced way and put them together and everything. So, that's also one way of doing that. And with windowing is that you can actually process your data depending on when they arrive, and like for example, for each hour and things like that. And then you can put them in the buckets. Then you can actually sort them. You can say, hey, well, I found this piece of data that's supposed to be from this time and everything. So, you can do all these kind of things. Another thing that you don't really have to sort your data by time. You can also, for example, if you're doing like things like, I don't know, games and things like that, for instance, you might want to sort your data by sessions instead. So user sessions, for example, that's much more important than when it's happened. It's more who did that. So you can do that as well. I want to mention a few cool features that I kind of discovered and I've been playing around with, and it's kind of really, I liked. I mean, some of them are kind of basic and you probably have seen that before, but some, hopefully not all of them. So one of them is that I really like this elegance of like how simple it is. You can just apply windowing. So for example, here you can look at the data. You can extract your data for the last 5 minutes, and you extract that every minute. So every minute something wakes up and picks up last 5 minutes worth of data and does something with it. And this is how you do it. So you do a sliding window off duration, blah, blah, 5 minutes, every duration, blah, blah, 1 minute, and that's it. So it's kind of cool. The other thing is that you can do is that is kind of a bit less documented. It took me some time to figure it out. And then after figuring it out, I was surprised how simple and easy that was. And then I wrote a blog post about it. So there is this thing of visualization. So the visualizations, oh God, that's a funny word to pronounce. So visualizations that you saw earlier, they were made by the cloud provider. And those are specific to that cloud provider. So if you want to do your own visualizations, you have to do some magic. And it took me some time to actually figure out what and how that can be done. And I wrote a blog post. So at the bottom here, you'll see the link. So you can click, and it basically generates a dot file where you can visualize. You can convert it to a PNG or whatever. It's not as beautiful as you will see on the cloud, but you can do some other things to it to make it a bit more understandable and beautiful and everything. But the point is that you can actually visualize your pipeline as well without putting it into the cloud if you don't have to. And the other cool thing is that you can just redirect your stream of data or your pipeline of data. You just add another piece of it and you remove another one. So in the beginning, I was reading from files locally and writing to files locally. So now I wanted to read from files locally and store it, for example, into a data warehouse, into BigQuery that I ended up using at the end. And for me, it was just to replace and apply to my pipeline and do some specific things for the BigQuery, like defining a schema and things like that you have to do. But it was very simple. You just like do it with a few lines of code and bam, you're done. And well, so this is the way you replace it. So first I had this way of, if you see at the last line there, I wrote things to file. But then I removed the two last lines of apply, and then I added two more other apply lines where I kind of process it in the way I want it and put it into a BigQuery table in this case. But it could have been anything else. It could have been like, well, any database or files or whatever that might work for you. And the other cool thing was that I could actually also put into I could also put into another database and just like redirect stream. And a colleague of mine, he is a very big fan of this database, which is also open source, ArangoDB. And he was like, hey, give me this stream of data, or like give me some access to this data, and I'll just create a visualization in no time. And then 15 minutes later, we had a map with all the stations on the map, with all the average availability. I mean, it's like 15 minutes work, so it's probably not the most beautiful thing you've seen in your life, but still, I mean, in 15 minutes you had this thing with average floating kind of availability of that particular bike station and things like that, which was cool. So then I could do some stuff, and I could do some quite actually a lot of stuff. So we ended up writing quite complicated queries to find the least busy stop for bicycles, the most busy one, the one that had more stops more bicycles that were out of order, and things like that, locks that were out of order. So we can actually get a lot of fun information out of this thing just by collecting probably around a year worth of data, and that was quite fun. That was fun times. So the queries got really big, but then this is how it is with data, right? And well, back to Amazed Monkey, and you're like, "Whoa, this was too easy." Like this was my first impression as well. There are a few warnings that I want to mention at the end before finishing off. Is that the thing is that the pipeline is, you don't really have to change, but your data might change, and the moment your data changes, it will kind of mess up things for you. So what will happen is that, for example, the endpoint that I was using, they switched their solution from one piece of code, I think, from one kind of piece of software to another, and they changed a bit of the structure of the files, and it broke my pipeline. So the data will change, and at some point you will have to fix your data. It's not a magic bullet that will kind of fix everything, but still, you don't have to think about a lot of things, but some things you will still have to manage. So if your data changes, and it will fail, and you will have to fix it, and it's a bit kind of weird to debug it sometimes. That might be a bit of a challenge, but the whole code and everything is open source, and it's all available on my GitHub. I mean, it's kind of work in progress. It's kind of my hobby project, so it's probably not the most maintained and beautiful piece of software I've written, but it was like my kind of playground. It was my place where I would experiment with things and play around with things, and the main branch of it should run with description and everything. So if you want, you can have a look and play around with it as well. I have some simple sample data as well. So that's pretty much it. That's what I had for you today. This is contact information. This is me on Twitter. So the first one you see there, and I'm also on. You can find me online on my blog, and also ping me on email and everything. So there are a few questions that are that came in. So I'll do my best answering those. And in the meantime, feel free to ask more. Apache Beam was the only tool that allows to batch and stream data simultaneously. Well, no, it's not the only tool. I mean, there are a lot of tools, but I mean, for me, it wasn't like selecting the best tool, but I wanted to do this thing of experimenting with Apache Beam, and I saw this thing that would do both batch and stream as well, and the same model. And I'm not sure. I don't. There are probably some other tools that do that as well, but that was in my kind of experience was a very simple way of combining both of those, even though I didn't really use much yet of the streaming part. So I can, for example, add weather data and stuff like that comes in as a stream, and then I can have another pipeline for that. I mean, you could have solved that with other tools definitely as well, but for me it was again, I wanted to learn Beam, and I wanted to play around with my data, and that tool really worked really nicely and well for me. So that was cool. And another plus probably was that it had this simple integration with a cloud. So I didn't have to run it all on my tiny little Raspberry Pi that kind of died halfway through the project as well. So I was happy that my files and stuff weren't on just that little SD card. More details about the synchronization mechanism behind Apache Beam. Well, I mean, the synchronization mechanisms, I'm not an expert on Apache Beam, so I can't tell much how it's implemented, but it's doing a lot of magic. I mean, it's doing a lot of smart kind of guessing in the back, and then we'll try to figure out how things are, how many workers it needs and everything. So I never had to write anything or like suggest number of workers and stuff like that. That was also a very nice thing. It would kind of even on my local machine, it will also look how many cores I have, how many threads it can run, and things like that, and we'll just kind of adjust according to that. Any more questions? If there will be no questioners appearing very, very soon, I'll probably give the word back to you guys in GDG Tech Sessions.
Yeah, Rustam, thank you a lot. I think besides you're presenting the functionalities about the Apache Beam, to construct or to build data pipelines, you also tell us a story and how we can solve a real problem that in this moment happens in your city. And of course, I hope that people that are assisting us, or they will assist us, they can reply and copy that kind of solution for the city and for the problems. And of course, it's clearly a good contribution that you made for the open source community, and I'm glad to have you here presenting and sharing this solution for us. So Rustam, thank you a lot for being here and for this amazing presentation.
Thank you very much. Well, I mean, I have like two actually. If you have to go with like a few things in your mind from this talk, I would like to ask you to play around and, well, first contribute to open source, and the other one, play around with and find fun projects to play around while you learn things. And that's also another thing. It's just like, data pipelines might be a bit hard to learn and to understand just if you just have to do it. But when you have a bit more fun project and can actually get something out of it, that might be much more fun. So, do that and share. And also the other one is obviously sharing your experiences. That's also always really cool.
Yeah, of course. And people that are seeing us, they are elucidated how we can improve and solve real problems. So I think it's great. So again, Rustam, thank you a lot for your presentation.
Thank you very much for having me. It's been really, really fun.
Thank you again. So presenting about the next event, about the DevFest Tech session, it will be in 18th of October, and we will have two talks, one from Adi Mazur-Cario, talking about voice emotional design, and also with the project data. They will talking with us about TensorFlow. I will hope to you to join us in this day and then assist with us the DevFest and this content that we've prepared for you. Don't forget that you can always propose a tech session. Just fill this form and we will contact you to get all the things ready. And just to wrap up the event, follow us on our social media to get updated on the last news. Just want to thank all the team that make this initiative possible, and mainly to our speaker, Rustam Mehmandarov, and also to the GDG Cloud Oslo that make and participate in this tech session. Thank you everyone for joining us. Hope you enjoyed a lot and hope to see you soon. Goodbye.